Number 22, find the length of the curve. Y is equal to x cubed divided by 4 plus 1 over 3x, where x is running from 1 to 2. So how do we do this? We should know that we need to take the derivative. So we have y as a function of x. We're going to take the derivative and square it, because our overall formula is we're going to have integral from, in this case, 1 to 2 of the square root of 1 plus y prime of x, all of that squared, dx. So we're going to take the derivative, we'll square the derivative, we'll add 1 to that, and then we'll take the square root. Okay, so without further ado, let's go ahead and start crunching through all of those steps. So y prime of x is going to be 3x squared over 4. The derivative of 1 over 3x, this is equal to 1/3 x to the minus 1. So the derivative of this is minus 1/3 x to the minus 2. Okay, so that's y prime of x. Let's square it. So it's going to be all of this squared. And this crunches out as 9 over 16 x to the 4th. So that's this term squared. And I multiply the two terms together and then multiply it by 2. So minus 3/4 x squared times 1/3 x to the minus 2 times 2, because there will be 2 of those cross terms, plus 1/9, I'm squaring this term now, x to the minus 4th. Okay, so this can simplify a little bit. This first term won't simplify, just 9/16 x to the 4th. This, though, will simplify a good deal. How far can we simplify it? Let's see here. Those 3's will cancel, and those x squared and x to the minus 2 will cancel, and we'll just have 1/2, minus 1/2. And then plus 1/9 x to the minus 4th. Okay, so we now have y prime of x squared. We now want to add 1 to it. So 1 plus y prime of x squared, 9 over 16 x to the 4th, plus 1/2 plus, so 1/9 x to the minus 4th, minus 1/2 plus 1 gives us plus 1/2. So now we need to take the square root, 1 plus y prime of x squared. And so this ends up as, so we want to take the square root of 9 over 16 x to the 4th plus 1/2 plus 1/9 x to the minus 4th. So it's going to take a little bit of time to crunch this out. Let me show you how I would approach this. We basically, our goal here is to write 9 over 16 x to the 4th plus 1/2 plus 1/9 x to the minus 4th. We want to write this as a perfect square. How do we do that? So a couple of things I'm going to do. I'm going to clear out negative powers of x. So I'm going to factor out a factor of x to the minus 4 from each of these terms. So this would give me 9 over 16 x to the 8th plus 1/2 x to the 4th plus 1/9. So what did I just accomplish here? None of the powers of x here are negative. If you're unsure about why this is equal to this, just multiply back through, and you'll see you end up with this. Now I'm also going to pull out a factor of 1/9 here as well. So this is going to correspond to multiplying everything here by 9. And so that's going to give 1 plus 9/2 x to the 4th plus 81 over 16 x to the 8th. Now, if you still are having trouble seeing this, you could pull out a 16 from all of this. But I think at this point I'm able to kind of spot that this is a perfect square here. What is the perfect square? So 1/9 x to the minus 4th times 81 over 16, that's 9 over 4 squared. X to the 8th is going to be x to the 4th squared. And I see that kind of stuff going on in here. So this is going to be 9 over 4, x to the 4th, plus 1, all of that squared. Because when you square this out, you get, I'm just squaring the thing in there, 9 over 4 squared, x to the 4 squared is x to the 8th, plus 2 times 9 over 4, x to the 4th times 1, plus 1. And this ends up as this ends up as this. So hooray, this is a perfect square. This is just 1/3 x to the minus 2 squared. And so this square root ends up just being the square root of all of this. It's just 1/3 x to the minus 2 times 9 over 4 x to the 4th plus 1. So we've done the majority of the work on the problem right now. All we have to do is plop in this in here to our integrand and integrate from 1 to 2. So what happens now? The integral from 1 to 2 of this expression right here, 1/3 x to the minus 2, 9/4 x to the 4th plus 1. So this is 1/3 times the integral from 1 to 2. I'm going to multiply that through 9 over 4. X to the 4th times x to the minus 2 is x squared plus x to the minus 2 dx. And this gives us 1/3 times 9 over 4 times x cubed. And then we have to divide by 3. And then plus 1/3 x to the minus 2 goes to x to the minus 1. But we have to divide by minus 1, which is multiplying by minus 1. And plug in 1 and 2. Some things should cancel here. And so we should end up with 1/4 times 2 cubed minus 1/3 times 1/2. So that's what I get when I plug in 2, minus 1/4 times 1 cubed minus 1/3 times 1 over 1. So whatever that simplifies down to, that is your final answer. So this is relatively straightforward. To recap, this is a relatively straightforward application of our arc length formula. The thing that just takes a lot of time is being able to see how this is a perfect square. So these kind of problems are good to practice.